Hi, this video is for Monday, May 4th for 6th graders in science. The book looks like this. This should look somewhat familiar. Last time we were doing oceans, and guess what? We still are, just a little bit different. We're now in 11.2. It's a whole new section. Also, this section is rather big, rather large. So what I'm doing is today's video will be half of it. Wednesday's lesson will be the second half. So let's get into it. Ocean currents. Now, feel free to pause this video because one of your questions is going to be about the yellow word ocean currents. Okay, what are ocean currents? I mean, it's the title of our section. Now, if you look at this picture here, I also included a copy of this. There's water that basically moves, and it's almost like a river. And I know it's hard to understand, but it's like a river in the ocean. And what do they move? Like, where's the water going? Well, the water moves heat, other water, animals, plants, nutrients, and even humans because we're on ships from place to place in the ocean. Now, let me say that one more time. What is the water moving? It's like that pink red line. It moves heat, water, nutrients, animals, plants, and even humans that are on boats and ships. Now, the most example is from the original Finding Nemo, not Finding Dory, where Crush, the turtle, and his dad and his crew of turtles, sea turtles or tortoises, they go on like this freeway in the water. They're actually on an ocean current. Those are real things. I know it's weird from a Disney movie, but it's real. Let's go to the next page. Another question your Google Doc is going to ask something about this too, this heat map. Okay, one of the questions it's going to ask, on a hot summer day, the land where humans are is going to be hot red. The ground, think of when you go to the beach on a summer and you take your sandals or your shoes or your socks off, it burns your feet. But then when you stick your toe into the cold ocean, the cool breeze, the ocean, it feels wonderful. So the question's going to ask, why is everything red, but then the water is cold? That doesn't make any sense. The answer is in this section, so feel free to pause it there. But I'll also say the answer with my words. The answer is that it's right here. It takes 5 times more heat to change the temperature of an area of water than it does to change the area of sand. So it takes longer to make water hot. Think of it as when you're cooking, because a lot of you are probably stuck at home and you boil water for macaroni or for spaghetti or for whatever. It will bubble and get hot and boil, but it does take several minutes. Now, you could zap it in the microwave and it'll get hot in a minute or two. But water just takes a longer time to boil, to heat up. Land, like asphalt or blacktop or sand, gets hotter at a quicker pace. Let's go to the next page. Our book also is telling us that on a calm day, right here, you won't see as many what's called white caps. The little white looking foam there. But on a windy day, you'll see like a lot of mist, or it's like a cloud. Those are called white caps. There's no question in Google Docs. I just think it's sort of neat. Next time you go to the beach, see if you see any white caps, then it's a windy day. In your Google Doc, you do have a question on the Coriolis effect. This one right here. Okay. Here's what that means. Okay, this might be a little confusing. I'll try to do my best job to explain it. Okay, the water is moving in different directions at the same time, depending on where you are in the earth. Okay. This is the middle of the earth. That's called the equator. Everything on the top is called the northern hemisphere. The N stands for north. Everything below it is called the southern hemisphere, as it tells you right here too. We would live in the north, up and to the left. We live in the north, so we would live over here. Now, what this map shows you, feel free to pause it, is it tells you which way the water current is moving based on the Coriolis effect. Because remember, we're spinning in space. We're also rotating elliptically around the sun. We're moving. There's gravity. There's wind. There's other factors. There's the moon that creates tides, 4 tides a day. It causes the water to do sort of funky stuff. So in the middle here, the water goes up and west. But in the south, the water goes down and to the east. If you follow the arrows, that's the way the current is moving. So sailors, humans, and animals have used these different currents to help them. Last page for today, let me zoom out, is it's going to ask a question about the salt in the water. So if you want to pause it right here, there's a copy of this again in your Google Classroom. The amount of salt that is dissolved in quantity of water is called salinity. Now, the question's going to ask, when there's more salt in the water, so what? What does that mean? The answer's down here. I'll let you read that for yourself. I'm sure you've been to the beach and you've accidentally opened your mouth during a wave and the water is disgusting. It's because of the salt, well, and pollution, of course. But the answer to the Google Doc question about salt, if you pause it, is where my finger is till the period. So feel free to pause. Instead of me telling you, I'll let you read it a little bit. And the last part for today, and then we're going to end the video. There's also water that's frozen called glaciers. And what's crazy is if you see like an iceberg from the famous movie Titanic that came out in 1997, the ship hit the iceberg, but there's water that's underneath that iceberg too. Remember the sea floor, that's from last section of the ground. Feel free to pause this too. There's no question on the Google Doc. This is just sort of interesting. There's also leftover, it looks like sprinkled of salt and pepper. There's leftover salt. And then the cold air skis and like a snowboarder goes down the glacier to the water. I hope this video helped you with your work today. See you next time.